Welcome to today's lesson on derivatives and their powerful role in calculus. A derivative is the rate of change that unlocks hidden truths. A derivative measures the rate of change at a specific instant. A derivative calculates how a function changes at that exact moment. The slope equals the limit of the difference quotient divided by delta x. First, subtract two close values to find the average rate. Then, shrink the distance between points until the gap approaches zero. Next, divide the change in function value by the tiny change in input. Finally, the resulting number represents the instantaneous derivative value. There are 5 main categories of financial derivatives listed below: forwards, futures, options, swaps, and collars. The price of a stock derivative typically fluctuates according to the current market volatility index. When two forces collide, the resulting velocity depends on their masses multiplied by the relative speed. A bank uses calculus to determine whether a loan portfolio will grow or shrink over the next quarter. Every calculation involving change begins with finding the slope of a tangent line to the curve. Scientists discovered that the derivative of any polynomial never equals zero within its entire domain range. The average human brain requires approximately 69 minutes to complete one thought cycle and shift focus. A single derivative can determine whether a stock crashes or rises based on its exact instant value at a millisecond. The percentage error in this approximation decreases rapidly as the distance between points shrinks to zero. The concept of instantaneous rate of change dates back over 2,000 years to Euclid's geometry books written on papyrus scrolls. Derivatives were first created in ancient Egypt to measure the length of river segments they had to survey for building projects. Every time you calculate your tip for a restaurant meal, you are performing an instantaneous derivative calculation on your bill. Scientists discovered that the speed of sound in water is 4,913 times faster than the speed of sound in dry air at sea level. If you found this useful, please like, share, and subscribe.